Okay, it's working now. So these are the three laws that we would be using. Right? These are the laws that define how to get an inequality when a log function is given. And what these mean is that we are they are just using properties of logs to come out with equations. The first of them is that we all know that every log function can't be negative. So once I'm having a function like log, no, this is too big. Let me make it a bit smaller. Let me see. Okay, let me clear this. So once I'm having a log function, so let's have log x. I don't know the value of my x, but one thing that I'm sure of is that x is greater than 0, because we can't have log of negative numbers. And that's what this first law, that's what this b is saying. That if I'm having y is equal to the base a of x, one thing I know for sure is that x is greater than 0, and this becomes my first equation. Please hope that this first point is clear. Right, this is the first point that we are having. Now the second one that we are having is that provided I'm having two log functions, in this case I'm having log to the base a of x, which is greater than log to the base a of y. Provided that this base a I'm having down here, the base a is greater than 1, then I can conclude that this is an increasing function. And because this is an increasing function, my x becomes automatically greater than my y. Why aren't you? Okay. Yes. And the final one that we are having says that provided a is less than 1, right? So if a is 0.5, a is 0.4, then we have the reverse of these that we are having. We have the reverse of this, where if log to the base a of x is greater than log to the base a of y, then we have what? We have y to be rather, or let's say we have x to be less than y. So the difference is in the value of the a. If a is greater than 1, then we can also conclude that x follows the same trend, x is greater than y. But if the value of a is a decimal, is that correct? If it's less than 1, let me put it that way, right? Then we can conclude that um x is not greater, but x is less. I'm looking for my cursor. Just a minute. Um, yes. So now x is less than 1. And the value of a, oh wow. When the value of a is less than 1, this is basically what these three laws are saying, right? So let's pick some examples and let's see how we go about them. So the first one, we are having log to the base 3, log to the base 3 of 2x plus 3 greater than log to the base 3 of 3x. This is the question that we are having, right? And the first equation that we can derive from this is that we all know that every log should be positive. Therefore, every log is greater than 0. This is our equation 1, and this is our equation 2. 3x is greater than 0. This is our second equation, right? And from the value of the base 3, which is greater than 0, we can have our third equation, which is what? 2x plus 3 is greater than 3x. Why is it greater? It's greater because our 3 is greater than 0. Therefore, it's an increasing function. So we just proceed with 2x plus 3 is greater than 3x. Please hope that's clear. So these three equations that we are having, we can find the value of x. So from the first equation, from equation 1, we have 2x is greater than negative 3, right? So x is greater than negative 1.5, which is the same as 3 on 2, right? This is the first one that we are having. This is our first um, simplified form of the equation. The second one, we are having x is greater than 0, right? Just cancel both sides by 3. The final one that we are having is, we need to simplify it a little bit. So we have 2x minus 3x is greater than negative 3. So we have negative x is greater than negative 3, and we have x is less than 3. The reason why x is less than 3 is that we are cancelling both sides by a negative number. So once you do that, the sign must also change. Hope that's clear. You can also do this way. Instead of taking the x to the other side, we move it to the opposite side, right? So from this point, we can have 3 is greater than 3x minus 2x. So we obtain 3 is greater than x, and this is the same as x is greater than 3. The sign the greater than is facing should not change. This is what this equation means. If 3 is greater than x, once you move the x to the other side, or once you swap the positions, the greater or the less than sign should face the variable that it was facing before the swap. So you don't have to confuse them. Do we get it? So let me clean this and let's proceed. These are the three equations that we are having. Alright, so let's try and plot them on the number line. I can see 1.5, I can see 0, and I can see 3. So my maximum value would obviously be 4 or something, right? 3, and I have my 4, negative 1, negative 2, negative 3, and negative 4. So from this, I can plot my 1.5. So my 1.5 goes in the opposite direction of my greater than sign. So instead of going to the left, it goes to the right. Right? This is what we are having. X is greater than 0. X is greater than 0 also goes to the opposite direction. This is how we draw number lines, right? The direction that, if your greater sign is facing this way, your arrow goes like this, right? That's how we plot on a number line. And this makes sense because you are telling me that x is greater than 0. So x includes all values which are above 0 on the number line. This makes sense, right? And please, can you hear me? It's like I've been speaking for a while now, no feedback. Am I visible? Am I visible? Sure, sure, sure. Hello, can I call you back in 5 minutes? Sorry, not in 5 minutes. Like 1 hour time. Bye. So we are having our final equation, which is 3 is less than x is less than 3, right? So x is less than 3. This is 3. X is less than 3. So we have this number line. Right? It can go on and on and on. Now the second thing we have to do is to cut the point where we are having all three the last points of each side of the equation. Right? We want a section that each side of the equation is represented. And this is the point. So our number line now becomes what? 0 less than x less than 3. And as you can see, I'm not having 0 is less or equal to, because this sign stands for only less, right? You have less than or equal to this sign if it's stated in your question, right? And in that case, your number line, this side will be added. Please, do we get it? So this becomes our final answer. Let's see the answer they had in the slides and see if it conforms to what we've done. So they had the same thing, right? 0 is less than x, less than um, 3 as well. Wow, what's this? What's this thing doing? So I'm going to give us one example, right? One example. I'm stopping this recording.